Tutorial sheet 4, question 6, another superhet question. So we have a receiver of a double superhet type, which I've drawn down here, and that receives signals from a weather satellite at 136 megahertz. In other words, FRF is equal to 136 megahertz. The receiver first and second IFs are 30 and 10 megahertz. So the first IF1 is equal to 30 megahertz, and FIF2 is equal to 10 megahertz. The first local oscillator operates below the signal frequency, so FLO1 is less than FRF, and the second operates above the first IF, so FLO2 is greater than FIF1. So that's the information, all the information that we're given. And it's the first part of the question says determine the image frequencies. So first of all, we need to determine the image frequency for the first stage of the system. So we know that we've got an RF frequency of 136 megahertz coming in, and that 30 megahertz will be coming out. And we also know that the local oscillator is less than our RF frequency. So that means that our first image frequency is going to be twice the IF below our RF frequency, because it's going to mix with the local oscillator to produce something that is at 30 megahertz. So it's going to be 136 minus 2 times 30, which is equal to 76 megahertz. This means that if 76 megahertz signal comes in here, it will mix with our local oscillator to produce a difference between the local oscillator and the RF, being the IF of 30 megahertz. So that's our first image frequency, image 1. Our second image frequency is related to the second stage, and we know in this case that we have an IF of 10 megahertz, and we also know that our local oscillator is greater than our FIF1. So that our second image frequency is going to be double the IF, and in this case it's double the IF above 30 megahertz due to the fact that we have our local oscillator being above our IF. So we're going to have our image frequency for our second image frequency is going to be 30 plus 2 times 10, which is equal to 50 megahertz. So these are our two image frequencies, first one for the first stage, next one for the second stage. The next part of the question asks what other signal frequencies will cause second IF image problems. So what this means is what other signals that could be outside on the antenna could make their way through the system to be at this second image frequency of 50 megahertz. Obviously, if a signal of 76 megahertz comes in through here, that will be converted down to 30 megahertz. But there's also a problem if a signal gets to this part of the system at 50 megahertz. So what possible frequencies could get in through here that will be mixed with our local oscillator to give us 50 megahertz, which will then be mixed by the second local oscillator to give us 10 megahertz, and that will then cause interference. So what we need to do there is potentially work out what the local oscillator frequency is. So our local oscillator can be worked out by this. So FRF minus FLO has got to be equal to our IF, which is 30 megahertz. So in other words, our FLO is equal to 136 minus 30, which is 106 megahertz. So this is going to be our local oscillator frequency. So another signal could get through here and mix with this local oscillator to get down to 50 megahertz. So there's two frequencies that could do that. So we've got to work out what the third and fourth, essentially, image frequencies are going to be. So what we're going to have is that F3 minus FLO1 could be 50 megahertz, and also FLO1 minus another frequency, F4, could also be 50 megahertz. So from this we have that F3 is going to be 50 plus our local oscillator 106, so that's 156 megahertz, and F4 is going to be our local oscillator minus 50, which is obviously 106 minus 50, which is equal to 56 megahertz. So we have these four frequencies that could cause us problems. So just to recap there, so if this 76 megahertz frequency is somewhere over here, that will go through the antenna, be mixed by this first mixer, and that will convert down to 30 megahertz. And if 30 megahertz exists here, that will quite easily convert down to 10 megahertz through this second mixer. The second image frequency is purely just down to this signal. So if, for instance, 50 megahertz came through here, it actually wouldn't cause us a problem because it would convert down to a completely different frequency. So any signal at 50 megahertz would actually have to couple in somewhere directly into this system, which might not cause us a problem. However, these other two frequencies could exist outside the system that could couple in through the antenna, and if either 156 or 56 megahertz comes in through here, they will mix with this local oscillator to produce a signal at this set point here, which will be at 50 megahertz. And 50 megahertz will then mix with the second mixer down to 10 megahertz, and that's where you'll get interference caused.